Okay. More absorbed if it goes straight, more bouncing off if it goes at a low angle. This can be seen in a number of cases. I've got a friend who was in Alabama, but now teaching up at App State, and he got a good price on a house on a north-facing slope. Then winter came, and he found out why it was at a good price. He was snowed in a lot longer than other folks. You often see difference in what lives if you have a, for our part of the world, north-facing slope. The sun is to the south of us in the sky, so the north-facing slope is going to be shady. Having cooler conditions, more moist, different things like to live there than on the south-facing slope that gets lots of sunshine. For example, if you like going rafting up in the mountains, at least when I went to the Nantahala River, they told us that Nantahala was from Cherokee, meaning land of the noonday sun, meaning that the river valley was narrow and deep enough that you only got sunshine in there when the sun was close to overhead. So it stays relatively cool in there even on a warm summer day. At a much smaller scale, for your house, where might you want trees to be? Well, come winter time, you don't want that north wind blowing on your house, cooling things off. So if you have some pine trees planted on the north side, that'll help block the wind. But winter, you're wanting that sunshine. So you don't want anything that's blocking the light to the south side of your house. Come summertime, however, and blocking some of that light sounds like a good idea. You want shade. So if you have deciduous trees on the south side of your house, that'll help provide more shade in the summer while letting the sunshine warm you up in the winter. Another example, house here, and okay, there's more snow in the yard because that's a remnant of a snow fort, but look on the garage roof. This side still has snow, this side doesn't. This is the north side of the building. Here's the south. So this stays in the shade. Snow lasted longer on that side. Another reason why the sun being overhead gives you more energy than being low in the sky is how much area any one bit of sunshine is shining on. If the sun's coming in nearly straight down, that sunlight's concentrated on a relatively small spot. If it's coming in at more of an angle, the sunshine's going to be spread over a much bigger space. This is familiar, say, with a flashlight, even the pointer on here, if it will light up. Pointing straight in, I get a small dot. But if I angle it, that dot's now spread out into a line. One bit of the screen is getting somewhat less of the laser pointing than it did when it was more straight on. You can do this with a flashlight as well, quite nicely. Or think about your shadow, different times of day. You're blocking the light for a much bigger chunk of ground when the sun is low in the sky than when it's high in the sky. Another difference, how much air is the sunshine going through? If the sun is close to straight overhead, that light's going straight through the air. Shortest possible time in the air, least chance for it to run into something and get reflected or absorbed or something up there and never make it down to us. But if that sunlight's coming in at a much lower angle relative to the Earth's surface, you're going through a whole lot more air before finally reaching the ground, because you're going through the air much more diagonally rather than straight through. Going through more air, more of that light's going to be reflected or absorbed or scattered somewhere up there, never come down to warm us up. Again, a familiar pattern, especially if you've got relatively pale skin. What time of day are you at most risk of getting a sunburn? It's going to be near the middle of the day. Sun closest straight overhead, more of that UV makes it through the ozone layer all the way down to the surface. Low angle, much more that UV is lost, whether gotten by the ozone or scattered off, blocked by a cloud, something, and never gets down to the surface. Okay, so sun's angle, very important. Our angle relative to the sun changes through time. Earth has a couple of motions. We have the rotation on the axis, turning around every 24 hours, and also its revolution around the sun each year. Close to a circle, but not quite, a little bit elliptical. Also, Earth's axis is tilted compared to its orbit around the sun, about 23.5 degrees. So, as we go through the year, part of the time, the North Pole will be tilted more towards the sun, but as the Earth circles around, we'll also get to the point where the North Pole is pointed away from the sun, and the South Pole is pointing towards the sun. There are also long-term wobbles in the details of Earth's orbit. Earth gets a little bit more circular, a little less circular in its orbit. The exact angle varies back and forth a little bit. And over time, the direction of the tilt relative to stars changes so that what's now the North Star changes slightly over time. Now these are things that take 20,000 to 100, 400,000 years or more to complete the cycle. They're very long term, but these subtle wobbles in the Earth's orbit are enough to make the difference between, say, Canada's covered in glaciers versus glaciers melt back to just Greenland. So big impact on our climate patterns. These cycles are known as Milankovitch cycles after the astronomer working them out first. Okay, so Earth rotates on its axis. What sort of effect does that have on the amount of light we have? You've probably noticed it gets dark at night. Well, night, whichever art, when day is not. Shakespeare, or as Steve Martin said, a day without sunshine is like night. So, yeah, we have quite different amounts of light, day versus night. And this does affect what's going on with our weather and climate. Now, of course, 24 hours back and forth, that's relatively quick. A more dramatic difference is known, say, Mercury. It takes a whole 59 days to rotate, and by the time it's done that, it's also moved into orbit. So the actual time that one part of Mercury is facing the sun is even longer, and as a result, it's several hundred degrees warmer on the day versus the night side. Day-night changes also interact with other factors, such as heat capacity of water. Places with water change more slowly along with this day-night change. Places that are just land, bigger. daily pattern. Warms up, say summertime. Afternoon thunderstorms. Land warms up enough to get warm air rising and building into the thunderstorms. So day-night, lots of weather impacts.